The teacher says to her class, "Class, today we are going to learn about complementary angles." One of the students says, "Does that mean the angles are nice to each other?" She replies, "Well, they do the right thing." Get it? Complementary, right thing. Okay, so we are talking about complementary angles and other types of special angle pairs. And there are three basic types of pairs of angles you're going to see. Those that add up or sum to 90 degrees, so they make right angles. Those that sum to 180 degrees, so when you put them together, they add up to, they make a straight line or a straight angle. And then there are certain angle pairs that are actually congruent. They are always equal to each other in size. So first of all, one of the words we use are adjacent angles. So that are two angles that share a common vertex. So here's the vertex that you can see, and they also share a common side, which I'm highlighting in yellow here. So angle 1 and angle 2 are adjacent angles in this pair. Normally, when we make equations with these types of angles, if they're not a special 180 or 90 degree pair, then we use the angle addition postulate, where we say angle 1 plus angle 2 equals whatever the total size of the larger angle is. So we were doing that mostly when we did the angle addition postulate. Now, a linear pair is a special type of adjacent angle that forms a straight line. So you can see the straight line right here on the bottom. And so they have the non-common sides are actually opposite rays. So if I change my color here, you can see there's a ray. Here, change color. There's a ray, there we go, that starts here at the vertex and goes that way. And then there's an opposite ray going the other way. They both form, they're opposite rays, so they form a line. Now, linear pairs are always supplementary. What does supplementary mean? Well, supplementary means two angles that sum or add to 180 degrees and make a straight line. So you make your equations by adding the two angles, so angle 1 plus angle 2 equals 180. Get in the practice of writing an equation. Complementary angles are two angles that form a right angle. So when you put one angle, say a 30 and a 60 together, they always add up to 90 degrees. Now, one thing I should say about supplementary and complementary angles, they do not have to be adjacent, touching and sharing that common ray. They could be separated. Most of the problems you're going to work with, they will be adjacent. They will be touching. Now, vertical angles is a special angle pair that forms when you have two intersecting lines. And the angles kind of point at each other. So you could have, in fact, let me just quickly draw one for you so you can see. I thought I had one here on the screen. So if I had a line like this and another line intersecting it, the vertical angles would be the angle pairs that are right here. So this angle right here goes with that angle. All right. A special thing about vertical angles is that, hold on, let me come back to it. The special thing about vertical angles is that they are always congruent. So you can see the two red angles have the same measure, and my two yellow angles will have the same measure. The way you set up equations for these is you say angle 1 equals angle 2. Remember, with an equation, you need an equal sign. So now we're going to take a look at some of the different angle pairs in the following figure. To start, let me go ahead and look at the linear pair, also supplementary angle, angle 6 and angle 8. You can see they make 180 degrees, and they are linear pairs, and they are supplementary. I can say the same thing for angle 6 and angle 5. Now, another angle that I can look at is angle 8 and angle 5. That's that special vertical angle. So angle 8 and angle 5 actually have the same measures. They are congruent. So now that we've identified a few types of the angle pairs, we're going to use that information to find the values of the angles, the measures of the angles. So let's start here. We're starting with angle 20, 21, and 22. Here's 20, 21, and 22. You can see I've already highlighted a special relationship here. This 120-degree angle and angle 20 are a linear pair, which means I can say 120 plus this, that's not the degrees, that's just the name of the angle, adds up to 180. And there's my equation. Angle 20 plus 120 degrees equals 180. I subtract 120 from both sides, and I find out that angle 20 is 60 degrees. Now I look at another pair here. I can tell that this angle here with the square in it is a right angle, which means these other two angles also have to form a right angle. So angle 20 and angle 21, since I know angle 20 is 60, I put 60 in, they have to add up to 90 degrees. 60 degrees plus a measure of angle 21 is 90. I can subtract 60 from both sides, so I can solve for the measure of angle 21. And I get that measure of angle 21 is 30 degrees. Now I'm going to use another relationship. You can see that angle 20 and angle 22 are kind of pointing at each other across the intersection. Those are vertical angles. And vertical angles are always congruent. So I can say angle 20 is congruent to angle 22. So angle 20 is 60. So I fill in 60 for angle 20 and 22. Then I still have the 30 from there. And I already know the 90 because of the square. So I know all the angles in this picture. Here's a more complicated one. So the other one we had degrees. Now I have variables. But I'm still going to use the same basic ideas. First of all, I'm going to label both the angles I know. Angle ACE is 2x plus 3. Angle BCG is 5x plus 3. The next thing I'm going to notice is that there's a vertical angle pair here. So that means this angle is congruent to BCD. So I can put 2x plus 3 over there as well. Now that I have these two right next to each other, they're adjacent angles, I can see that they're a special angle pair that adds up to 90 degrees. So I set up an equation saying 2x plus 3 plus 5x plus 3 equals 90. Simplify my terms, 7x plus 6 equals 90. Then I can subtract 6 from both sides, so 7x is 84, which means that x is 12 when I divide both sides by 7. That gives me x, but I want the measure of every single angle in this picture. So what I'm going to do is put that value of x back into the angles. Let's start with ACE. 2 times 12 plus 3. So 2 times 12 is 24, plus 3, that's 27 degrees. Then that tells me that I'm kind of moving here because I had more space. These two are vertical angles, so I said 5x plus 3. 5 times 12 plus 3, 60 plus 3 is 63 degrees. This makes sense because we knew, if you look, there's a straight line here, and both these angles form 90 degrees when with that other 90 degree to make a 180. So this is a complementary pair. 63 plus 27 is 90, so that's good. Now that I know 90, 63, and 27, I can fill in all the angles using either vertical angles or complementary relationships. Angle 4, find the supplement of angle E. Now I'm going to make up a name for this supplement. I'm going to call it angle D, just to make life a little easier. All right, so measure of angle E plus a measure of angle D, that's what I'm actually looking for, equals 180. Now you're probably saying, well, you don't really know the measure of angle E. Well, it's 7x minus 12. So I substitute that in. And I want to get measure of angle D by itself. So first I add 12 to both sides. And then I subtract 7x from both sides. So I get measure of angle D equals 192 minus 7x. If you wrote the x term in front, that's fine. You could have also said it was negative 7x plus 192. This is the answer. There is no way that I can set it equal to something else with or set up an equation with another known number to find out what x is. In this case, you're just giving me an expression for the value of the supplement, the angle that adds up to 180 with. Now, if you wanted to, you could actually check it. So let me show you. You could say, okay, well, what's 192? If they're supplements, then I should be able to add them together, and what should I get? I should get 180 degrees. Well, those go away. 192 minus 12, that's 180 degrees. They are supplements. They add up to 180. Last but not least, example 5. An angle is 10 more than 3 times the measure of its complement. So I have to add 10, right, because 10 more, and I have to multiply by 3, all right? So then 3 times, and I'm going to call this x. We're calling the complement x. So find the measure of its complement. Complement means it adds up to 90 degrees. So I'm saying that this angle right here, which is 3x plus 10, plus x equals 90. Then I simplify by combining the x's. 4x plus 10 equals 90. Subtract 10 from both sides, and I get 4x equals 80. Divide everything by 4, and I get x equals 20. Well, the complement we said was 20. It was the x. So that means 20 degrees is actually the answer. So now for reflection. Can two vertical angles be supplementary? Can they be a linear pair? Why or why not? So it helps to draw a picture. You might want to draw 2 lines that cross each other. You may not want this angle for this particular question. You may want to try rotating them to see, can you make them supplementary? Can they be a linear pair? First of all, don't forget that vertical angles are the angles that aren't touching each other. For supplementary, the only definition is that the 2 angles have to add up to 180 degrees. They don't have to be touching each other. Linear pairs do have to be touching each other and adding up to 180 degrees. And remember, when I say touching each other, the more technical term is adjacent. Good luck.